Panoramic images are compelling because they are immersive. They communicate a sense of being there. Panoramas show a wide field of view, which lets us look around within a scene. However, panoramic images are not dynamic, so a panorama of this waterfall, for example, appears unnaturally frozen in time. A video, on the other hand, can show the motion of this waterfall, but still isn't immersive. It isn't panoramic, and it jars the viewer each time it loops. Video textures, introduced by Schuttel et al., solve the looping problem by creating a video that appears to play continuously forever. However, the result still isn't panoramic. In this paper, we introduce panoramic video textures. Panoramic video textures show dynamic imagery for the entire field of view, and can be seamlessly viewed for any length of time. Ideally, we would like to be able to create panoramic video textures without any special equipment beyond an ordinary video camera and a tripod. It would be nice if we could somehow just pan the camera slowly across a scene, and then create a panoramic video texture just from that. This introduces the key challenge. The input video, shown here at high speed, only captures the dynamics of a portion of the scene at any given time, while the output must show dynamic content at all times, everywhere. We begin by registering the input video frames into one global coordinate system. Then, the user draws a single rough mask that separates static and dynamic regions. We then create a static panorama for the static regions. Finally, we create a panoramic video texture for each dynamic region and composite them into the static panorama to create the final output. Here, we use our interactive viewer to navigate the result. The details of how we compute panoramic video textures can be found in the paper. For the rest of this video, we will show you results on 4 different scenes, including this waterfall. The best way to experience our results at their full resolution is to download them along with the interactive viewer from our project website. Here is the input video for another scene, played at high speed. And here is the panoramic video texture created from the input. This entire grove of trees is one dynamic region. Notice the rippling lake in the background. The middle portion of the scene is static. One frame of this panoramic video texture contains over 9 million pixels. The 2 trees form a single dynamic region. Finally, notice the gentle waving of the trees on the left. Here is another input video, played at high speed. And here is the output. The entire region of flags, as well as the highway in the back, is one dynamic region. The motion of the vehicles on the highway is visually seamless, though they often disappear behind the occluding boat masts. Here is the input video for our final scene. And the final result. This scene is composed of one large water region, flags, and tarps covering some of the boats that blow in the wind. In conclusion, we present a method for creating high-resolution panoramic video textures of a location. Panoramic video textures combine the wide field of view of panoramic photographs with the infinite length of video textures. The result is an immersive experience of being there.